Welcome to FOBtv, the future of business. I'm your host, Kevin Benedict. I am a futurist and lecturer here at TCS, and I want to welcome all of you to the show today. Here, we explore the forces shaping tomorrow's world of business, technology, and human intelligence. Now, to help us make sense of this evolving landscape, I'm joined by expert PLN. PLN, thanks for joining us today.
Thank you, Kevin.
Now, PLN is the global head of smart mobility and automotive manufacturing at Tata Consultancy Services. And again, I want to welcome you to the show. And for those that haven't met you before, PLN stands for what?
PLN stands for pretty long name. That's the acronym, but it's an acronym of my name, Lakshminarayanan Parthasarathy. But I think people remember when I say it's pretty long name.
Yes, pretty long name. There you go. So PLN it'll be. So where are you calling in from today, PLN?
I'm joining from my home office in Troy, Michigan.
It sounds like you're in the area where automobiles are manufactured.
Yep.
Let's do it. So when it comes to how consumers are experiencing their cars today, why have advancements been so gradual, PLN? It seems like we've been hearing about autonomous self-driving cars and fully electric cars that can go sufficiently long distances. But it seems like, to me at least, it seems like a slower pace than I expected. What's your thoughts?
Yeah, definitely. At first glance, right, the advancements seem a bit gradual, and there are some fundamental reasons for that perception. Again, it's a perception, I would say, and I will cover it why I'm saying it as a perception, right? So one, when it's a legacy manufacturing, right? There is a fundamental resistance to a change that exists because it's been 100 years of this is how we have manufactured things, this is how we have done things, and there is a resistance to change. Number one. Number two, it's a safety critical industry. You don't want to take shortcuts when it comes to either compliance or reliability, etc. So we need to make sure that it's a very, very rigorous process that needs to be tweaked to make things happen, right? But again, more importantly, while AI from a conversation, it's easy to look at AI as conversational from that perspective. But when it comes to integrating AI into manufacturing or into product design or to fundamental capabilities in the vehicle itself, it's a difficult process. I'll give you an example, right? When you talked about autonomous, while we talking about autonomy is easy, building autonomy is easy, but we always have this what we call as a long tail problem or edge case scenario when it comes to automotive. You can solve 98% of autonomous features easily. The last 2% is the long tail, and you don't want a vehicle on the road without addressing the 2% to avoid any fatal injuries or hazards or etc. Right? So that's why we have been talking about autonomous vehicle for last 10 years. Every time you hear Elon Musk say next year, right? So it's still we are next year. That's because we have made significant developments that has happened in that capability in autonomy. But to get to a car that is driving from anywhere to anywhere on its own, it's the long tail problem that needs to be addressed. But when it comes to product development, we have done a lot of, we have integrated AI in a much better way. For example, it used to be a 60-month product launch cycle in the past. We are working with our customers, and they are also developing a lot of things where it has come down to 36 months, 20 months. People are wanting to do it in less than 12 months. And that's a significant shift because sitting today, if I want to think what my customer will want 5 years down the line, it's pretty difficult. But it's easy to do what they need. Probably they need in 12 months time frame, right? So that's one where we, as a consumer, you and me don't see that steep exponential integration of AI, but that's something that as a manufacturer, it's something that they're doing. Lot more of AI is getting integrated into manufacturing, which again, as consumers, you and me don't see. Right? We only look at the features on the vehicle, but there is a lot of automation, there is a lot of AI, a lot of predictive capabilities that's there in today's manufacturing as compared to a few years back. We are in fact working with many customers, integrating robotics, integrating even quadrupeds, etc., in the manufacturing shop floor to address quality, to address safety, right, to bring in throughput improvement, etc. Right. So those are the things which are happening in the background. We don't see. As a consumer, all we want is to go from point A to point B, right? And there, those capabilities integrating into the vehicle is a little bit of a, I would say, something that needs to happen. But again, as a OEM, I want to monetize these capabilities. So which features are you and me willing to pay for, right? That's where I want to invest in, and that's a gradual process.
So let's kind of do a historical review, PLN. Let's look back at the last 10 years of automotive. What has changed over the last 10 years? Kind of catch us up to what we have solved and developed. And then let's extend that out another 10 years into the future. Where might we be in 10 years? So where have we come from over the last 10 years, and where do you think we'll be in 10 years?
Yeah, so definitely, if we look at it, right, it's like I said, it's no longer about just moving people and goods from point A to point B. That if I may say 10 years, but think of it as a little bit longer history, 20 years, or in this century, for example, right? So vehicles the pace has accelerated a lot in the last 10 years, right? We used to just have connected capabilities 15 years back, that just you can connect your phone to the vehicle and talk, right? That was the shift a few years back. But vehicles have evolved from being just connected to conversational, right? Now with a lot of generative AI integrated from pure conversational AI perspective, they are a lot more collaborative. There is integration with smart infrastructure. Vehicles can talk to each other for certain purposes. And now we are truly seeing autonomous capability, even driver assist capability. There is a significant amount of driver assist features in the vehicle today than 10 years back, right? Even vehicles can be autonomous, true autonomous on a highway at certain speeds today.
My new truck has 13 cameras. So what I'm struggling with right now is when it brings up this view on this big screen, I'm like, which one of the 13 views should I be looking for? And how do I coordinate all these views?
But you should be looking in front of the road than the screens. That's where the distraction starts happening, right? So definitely. So those are the things that has happened so far. But as a consumer, what am I looking for? I want and more capabilities in the vehicle, where I keep saying that we see vehicles or automotive as it's an extension of our living space. Whatever I can do sitting in my couch in my house, I want to do it in the car, right? Whether it's e-commerce, whether it's listening to the podcast, reading to a newspaper, attending Teams meeting, whatever it may be, right? I want to have that capability in my car. So I say it's an extension of my living space. Similarly, from a manufacturer, 20 years back, 15 years back, they sell, at least in the North America, they sell a car to a dealer, they forget about it, right? For them, it's a sale, it's a one-time sale of a vehicle. Today, they want customers for life. So they want to be invested and integrated and have access to the customer during the 10, 15 years that the vehicle is on the road. And when you bring in EV capabilities, that lot adds a little bit more complexity. So when you talk about advancements in the last 10 years, I talked about from an AI perspective, there is a significant improvement in electrification of the vehicle. There is significant improvement in the architectural change to software defined vehicle, right? So those are all happening. When we look at it from a future perspective, again, I will always say that it's a moving target. I wouldn't say that, okay, 10 years down the line, this is what I want it to be. But there are fundamental shifts that is happening, right? Again, a lot of them is driven by even political, environment, regulatory. I'll give an example. January of this year, we launched an e-mobility study. We captured the sentiments of OEMs, customers, regulators, etc. There is a significantly positive sentiment about EVs. I think 66% of respondents said that their next car needs to be an EV. But that time you had those government incentives and government support. If I go and ask the customers today, I'm sure their minds would have changed because of the current political environment, right? So there is always that gap between what the OEMs want, what the customers want, and where the infrastructure is. Is the EV charging infrastructure ready today, right? So there is a lot of that change. That's why in the tagline for my group, we call it as Thinkspiring the Future, a future that doesn't exist. But think about the future, and aspire about the future. The same goes for this industry also. I think it's a blue sky. Everything is possible when it comes to the future. Technology exists today, which we didn't have 10 years back, but applying the technology to make common sense capabilities into the product is something that I would see. I would like to see in the next 5-10 years.
That all makes sense to me. So let's kind of shift our discussion into how cars are made and the factories and what we're hearing about these factories. Now, we hear a lot about smart factories. What exactly does that mean?
See, when my view, and when the smart factories, as we say, right, they're all obviously connected. They're all connected enterprise which has its own intelligence. When I say it's a factory which is anticipatory, right? It's not reactive. It is anticipatory in that sense that they can proactively deal with the situation, as opposed to a factory that reacts to a situation. When we get to that point, that's a shift to becoming a smart factory. While I think there is a lot of narrative around smart factory means lights out factory or autonomous plants. I generally don't prescribe to that view because that is a goalpost. That's why we have a framework called Design for Intelligence in TCS, where we help our customers shift from being reactive to an adaptive enterprise, right? And I think from a TCS perpetually adaptive enterprise, and that's the anticipatory in nature. And in that, our focus is always focus on the KPI and grow and improve that KPI. Right? There's no goalpost that okay, and once I lights out, I am done with that plant. There's no room to grow, but even there's room to grow there, right? So from a plant perspective, conventional manufacturing enterprise, the conventional plants, right, they focus on continuous improvements, right, or in either people, process, technology to just improve the KPI, or it could be OE, it could be safety, quality, anything, etc. Right, and they've leveraged data, AI to improve this metric. That's the traditional approach. All right, when we talk about the shift from focus on autonomous plants or lights out plant, right, our vision is that these are factories that grow, and we believe that this framework will be designed with AI first mindset, right? And they can perceive, they can adapt to changes that because the manufacturing is a very dynamic process. The market is changing, the manufacturing process is changing, your supply network is very complex. How do you adapt on your own? You have the intelligence to adapt, right? That's where the smart factory starts coming up. It's not just putting together sensors on a device and connecting them. That's not going to that will get us the data that to make it adaptive, but that intelligence, when we build that intelligence, is when they become smart factories.
So for those that aren't as familiar with the whole factory process in automotive as you are, can you walk us through the progression of how the factories used to be run and to how they are different today? And then what's the next generation like? I imagine with automation and robotics, they design even, everything, and when resources come out and how they design to anticipate that robots will be building these things. So they must change the way they develop components and everything else so they can be managed and handled by robotics, I would think. Talk to us about that. How does a factory work different today than it did 10, 20 years ago?
The fundamentals of the assembly process when it comes to automotive has not changed a lot, but there are some significant shifts, like what used to be Henry Ford's approach 100 years back. If you look at it in the recent past, right, that the unicast model of Tesla's single shell is a fundamental shift, right? So that's a significant shift that's happening, and that's predominantly because of the level of automation that is available and involved, right? So there are things that are completely changing when it comes to that process, but the level of automation that is brought into the manufacturing process, right? That's lot has changed now that you have kind of highly smart devices, what I call as smart nodes. Your product itself, car could itself be a smart node. Your assembly line can be a smart node. Your AGVs can be a smart node from a material movement perspective. The safety systems can be a smart node. So how do you bring those smart nodes into the picture? More importantly, how you do the simulation first before you make changes in the line. That's where the entire concept of digital twin or software defined everything, software defined factories come into play. So when you abstract that hardware and the software in a plant, that's a fundamental shift today than it used to be in the past. Earlier, it used to be hardware driven manufacturing process, right? You have PLCs in the equipment and they are very hardware centric. Now very similar to the SDV, software-defined vehicle concept, when we talk about software-defined factories, and that's why you call software-defined everything in a broad sense. That's the abstraction and segregation of hardware and software separately. When you start driving the plants with software, and you can, through software, change the process controls in a plant, that's a fundamental shift when it comes to this introduction of robotics. And robotics has been there in the past also, but now we talk about physical AI, right? Bringing in physical AI, things that can actually move things and act physically. So far, what we have discussed about AI, it's about moving data. Now we are actually moving things in a plant with AI, right? So that's the physical AI part of it. So if you bring all this together, and that's been a shift. Yeah, obviously our entire dynamics of manufacturing has changed. We are in a completely global manufacturing scenario. Your supply chain is somewhere. You could be hit with while we used to have just-in-time manufacturing with my supplier just outside my door, sending me supplies every 90 minutes. That's not the case. Your supplier could be in China, it could be in Mexico, and it goes back and forth, even in our Canada, US, and Mexico.
And now you throw a bunch of tariffs into the mix.
Yes, right. And we have seen in the Europe that one small chip disaster, right? Recently, when the Dutch government acquired the Chinese one, many of the OEMs don't have supplies in the next. So those are the challenges that OEMs or manufacturers are operating in, and they need to be ready to address those and adapt these plans to these changes.
So you mentioned digital twins. Let's talk about that. What role does digital twins play in all this kind of modernization of an automated plant?
So it's a very critical tool. We have talked about digital twin for almost 15 years, but we didn't get the full benefit of it so far, purely because of the lack of technology. Because if you take 3 months to build a digital twin, by the time the physical world has changed a lot, so your digital twin is no longer relevant, right? So now, can we use technologies that's available, computer vision and data from the systems, to keep the digital twin and the physical world in completely in sync all the time? That's when you start seeing the benefit of this, right? Number one, when we talk about digital twin is both for the product, process, and the asset itself, right? And everything has to be maintained. Changes that we need to make in the line, if I can make it in a virtual world, test it out, and then bring it to the physical world, I can do it faster. Like, for example, OEMs typically have a week or a 2 week window of line shutdowns, either during summer or during Christmas, to make changes to the line, right? And that's when the rubber meets the road. Whatever they have planned, that changes to make the line, and during the 2 weeks, if they cannot get it done because they missed something, that okay, this change I thought will work is not going to work, they have a problem. So now we can do everything in the digital world, decide what parts I have to buy. Is it going to improve my OE? What are the safety challenges that I'm addressing, etc. Everything can be tested in the simulation world and then quickly implemented in a real line. Right? That's where, and the lot of what ifs, if what that we can do, you couldn't do it in a real world. You have to do it in the virtual world. And the foundation for doing that is the digital twin. If you don't have a digital twin, you can neither go and relive yesterday, saying that why a certain issue happened yesterday in the way it happened, or you cannot do a what if scenario for tomorrow, that okay, I want to make these changes. What it would mean to my inventory, what it will mean to my workforce, what it will mean to my safety, right? Anything, or my even just the OE, for example. If I have to do a 10-second improvement, what do I need to do?
And now we're having to simulate environments where there's humanoid robots walking around. I've been seeing more and more of these kind of YouTube videos and social media feeds where I think it was BMW had this whole line of humanoid robots walking around picking up parts and assembling them, and it looked like into the dashboard component of a car and all kinds of things. So how have you seen the role of robots evolve over the last 10 years?
The key difference, obviously, robotics has been there in manufacturing for quite some time, purely from an automation viewpoint. The change that we are talking now from a robotics is what I say is they are both situationally aware and contextually aware, right? Earlier robotics were not. They will just do, if you want to, it will automatically go a repetitive task
right
blindly, right? Now, the situational awareness and the contextual awareness is the key that is bringing AI, Gen AI into the manufacturing world, right? So obviously, I would definitely want to say that next time when you come to Troy, I'm sitting in Troy. I have a physical AI lab in Troy. We have humanoid quadrupeds in this facility, right? We are doing customer engagement, but we are also doing research with humanoid quadrupeds, etc. So, in fact, we are doing multiple programs today with our customers. And as I speak, my quadruped is walking in a facility today where the facility is going to come up in next year. As the building is coming up, my quadruped is doing the inspection, right?
So talk to PLN guys that are watching this. Talk to PLN about seeing some of that stuff.
Yep, definitely. So that's where where when the machines just don't execute instructions that we provide, but they can perceive, reason, and act intelligently. That's the difference in the robotics of today from the past. And that's what we broadly call it as a physical AI in manufacturing, when humans and robotics, these kind of humanoids, quadrupeds coexist. Right?
Oh, yeah.
There
So
used to be
you use the term, I mean, I've heard the term used of cobots and situational awareness, right? So now when they're needing to work alongside unpredictable humans, they need to understand that they have to be aware of where the humans are, unexpected activities by the humans, so they don't injure their cobot partner.
Yeah, see, definitely that's the very in the near future we will see humans and cobots or robotics coexist in a plant, right? And we want to see these robotics assets being rostered like another individual. I want to know what their skills are, what their capabilities are. Okay, instead of okay, PLN can do this thing, this humanoid can do this. Can I swap PLN with this for that work and give PLN some other work, right? They need to be rostered as another individual asset, right? So from a TCS standpoint, or the way we define it, it's the convergence of AI robotics. That's the physical AI that enables autonomous decision making in a dynamic field, right? It's always about enabling intelligent machines that go beyond automation to decision making. It could be robotics arms that can think, it can reason and adapt to complex tasks. It could be AGVs, AMRs, etc. I think the one thing that probably 1980s or 1990s, somebody said future of manufacturing would be just a human and a dog in a plant, right? The human to feed the dog and the dog to make sure that the humans don't touch the equipment, right? So I don't want to see that future, but I want to see humans and robotics dogs coexist, and they can seamlessly handle. And it will be multiple robots. It's not only quadruped. It could be a humanoid, quadruped, AGVs, right? A unitary this kind of UR robots, fixed arms, multiple things working, and if it can seamlessly pick up where a human has left, that's the world that we want to be in.
So PLN, can you believe that it was only 2023 or maybe 2022 when the world started embracing generative AI?
Yep.
And now listen to us talk about, oh yeah, in the lunchroom, we'll be sitting at the lunchroom next to a robot and they'll be watching us eat our sandwich.
Yeah. Probably take it and eat it.
Yeah, maybe we'll give him oil. Oh, that's crazy. Now, one of the things I've also heard a lot about this year from especially some of the prominent billionaires that are walking around is they're investing in energy, and they're really thinking that energy and the progress and evolution of energy generation is really getting close to just transforming the world. Matter of fact, Mustafa Suleyman, who's I think the president of Microsoft AI right now, and he's wrote, what is it, The Next Wave book, or he was just saying that he believes within the next 20 years, energy cost will be reduced by 95%. And then he said, can you imagine what if energy was only 5% of the cost it is today, how that will change the world? And he was talking about desalination, water desalination in deserts all around the world can be blooming with flowers because the price of generating energy is so little, you can just change where agriculture is, where humans live, all this. So I want to know if we get anywhere close to some of those huge aspirational visions, how's that going to impact manufacturing? Are there cheaper and cleaner energy sources that everyone's talking about that's coming to manufacturing that will change the way manufacturing operates?
See, the one reason for this focus, right? It's when as we AI is very energy intensive. Right? We don't realize that that every time you ask a question in ChatGPT or Perplexity or whatever, right? There's a significant amount of energy consumption that happens in the background because those data centers with GPUs they hog energy, right? So we have to be very conscious of abusing this entire thing and making it more energy dependent than we are already in manufacturing. So we have to. That's one reason why. Otherwise, manufacturing has been there, whether we use fossil fuel or not, right? That it consumes energy anyway. But with more and more AI coming in, that consumption, even from a product design process, I don't want to design a sustainable vehicle with processes that are unsustainable, right?
Mm-hmm.
So that's fundamentally, if I have to build a battery with unsustainable processes, and I can look cool with driving an EV, but the vehicle manufacturing itself has consumed so much of that energy that we lost that benefit, right? So that's why we talk about AI for goods, data center optimization, etc. From that angle, right? So that's one. That's why it's important. Energy. There are alternate energy sources that everybody is doing research. For example, increasing the battery range, for example, will reduce those kind of technological advancements that's happening in the product, right? Also, we are talking about SMRs, right? Small modular reactors, the nuclear ones, which are co-located and smaller, less than, I would say, like, I think 30 megawatt or something, right? That kind of a small plants, having gigafactories which are close by, right? So those are things that are happening in both product as well as identifying new energy sources. Also, we are looking at carbon neutral manufacturing, right? That takes us into the sustainability world, but how do I make manufacturing as a process more sustainable, right? New and new raw materials are being identified. Obviously, earlier we used to have raw materials but used to just export it. Now every country is trying to make themselves energy dependent or energy independent through
Right.
consuming it in the geography, in the market itself. So fundamentally those are things that is happening. So I'm definitely seeing that we need to be energy conscious whereas we integrate more AI into manufacturing process, because otherwise it can go out of control.
Wow. So I want to kind of envision the next level or the next stage of development for automotives out there. Imagine, if you would, cars that can learn because they're connected to outside data sources and AI, and they can start learning which intersections or roads are historically dangerous and accident prone, and how might a vehicle prepare itself in advance for weather, for dangerous roads, for parking lots notorious for having fender benders, or areas that historically have had high vehicle to pedestrian accident rates, so that the car can become actually perhaps even hypersensitive to those kinds of dangers and prepare itself in advance to drive in that area. Does that sound like what the future might bring? What's your thoughts?
Yeah, see, definitely, if we want to get to an L5 autonomous vehicle, these are things that we need, and that's what I said. That the 2% long tail that I talked about upfront is these are these challenges that we need to address. If the car cannot perceive its environment and take action, right, then we cannot rely on that vehicle to be autonomous. We have always will have a human controlling certain parts of the vehicle, right? So this is not something that we can dream of. If you aspire to have autonomous vehicle, these become your prerequisites. You need to have the vehicle, but then it's not the vehicle itself. it's the AI in the vehicle that needs this capability. You already have the cameras, radars, lidars, etc. that's perceiving, but the split second, nanosecond decision that the vehicle needs to take, right? It, even if it knows that okay, this particular road is accident prone, how does it navigate that road, right? That entire process
Right.
is something it's built into the AI. And all this smart infrastructure integration, vehicle to vehicle integration, all the technology exists, but how do we scale it up? And again, like what we talked about, humans and the robotics will coexist in a plant. You will have autonomous cars and self-driven cars coexist on a road. You cannot play by the same rules. You humans will be unreliable when driving a car sometimes. How does an autonomous car handle a human driving along with it and taking making some decision that may not be by the rules that the
Right.
autonomous vehicle has been trained on, right? So these, I think these are fundamentals that needs to be addressed, and that's where the we see that perception of gradual that you talked about in your first question. These are fundamental challenges that we need to address. If it's an empty road, nobody cares, right? If it's a, that's not going to be where you want to put these vehicles.
So if I'm understanding this right, you're saying the hardware is mostly there, and it's really about this software defined vehicle environment, right?
I'll tell you this, right? I'm sure. I think this was Nvidia CEO Jensen talked about it. When so far we have always seen a car or a truck or whatever as a depreciating asset. The day you take it out of your dealership, it starts reducing
Right.
in value, right? That's a depreciating asset. We will, in the near future, we will be at a point where vehicles are an appreciating asset, because you will, with through software you can add features on a vehicle to add value to that car. So
Wow.
the point at the time that you take it out of the dealer will be its lowest value. After that, it can increase in value through this software subscription models and capabilities that are being pushed into the vehicle through software. And that's where only that can happen only when you segregate or abstract hardware and software and add value through software. Otherwise, today's vehicle you cannot do that.
Oh yeah, so we're in this point right now where it's just annoying. You go to a dealer and you spend a lot of money to buy a brand new car, and then 90 days later they want you to subscribe to continue all of that for another, $400, and I'm like, wait. I just bought this car.
Exactly.
We're in that transitionary phase. So you mentioned earlier, you started talking a little bit about sustainability. So let's talk about some of that in the context of manufacturing. The phrase circular manufacturing gets pushed around a lot. What does that really mean, and how close are we? Are you seeing automotive manufacturers really take that seriously? Or is this a marketing exercise?
No, yes, they do, definitely. When it comes to circular manufacturing, right, it's about designing vehicles for durability, reuse, repair, remanufacturing, recycle, right? So it's what we call as 3R, 4R, whatever it is, right? So it's those entire concepts, if it is built from the design to manufacturing to consumption, right? That's where it becomes predominant. Obviously, one from a PR angle or from a cost perspective, right? We manufacturers are looking at it seriously, not so much from a sustainability goal, maybe some of them, but some are. There is very innovative examples of integrating sustainability into the product that's happening. Obviously, if you take about aluminum, steel, etc., that is easy. The people have done that. But when it comes to plastics, glass, sensors, the other electronics part of it, right? So there are certain challenges which needs to be addressed. I would say we are in the early stage of building a true circular car product, right? From a manufacturing standpoint, there has been regulatory push. There is always efforts there, but these challenges have to be addressed because cars have not been built for kind of an end of life disassembly and a manufacturing, but there are OEMs who are setting up facilities today, right, where they have a full end of life process for certain components of a vehicle, particularly battery, for example. We don't want them to go into a landfill, right? So there are components that are kind of designed today with circularity in mind, but there are some legacy processes, components that are not there yet. But it's an important thing that we need to consider. And obviously, there is always a question of economic viability. Do I want to pay $200 more for a certain component because it's sustainable versus not? Same question. How much I want to pay for a EV? How much premium I want to pay for a sustainable car? I don't know.
So PLN, when I was a teenager, I started doing some circular activities with my Mazda, the very first car I bought. One day I was driving through the neighborhood and saw the exact same model of Mazda in the bushes in the woods next to a house. So I went and bought it for $75. I brought it home, and every time a part would break on my Mazda, I would just take it from that one.
Yeah, exactly. Yeah. I think that comes from the consumer intent, right? That comes from a consumer intent.
Yeah. So let's talk about supply chains now. The global supply chains have been through a lot lately. I mean, politically, unpredictability, all of that. So how are car manufacturers approaching this? How are they rethinking, how are we going to do this so we can be less dependent on some of these variables that are shaking up the world?
Definitely, I think it has been several decades of work that we have to undo to fix some of the things that we have done, particularly from the US perspective, right? Nearshoring, localization. We talk about it's not that easy. We have dismantled some of the manufacturing capabilities in the country, which needs to come back, right? Trained workforce. I don't think that's a much bigger challenge for us, right? So definitely from our because of the global nature of the supply chain, building inventory, building buffers are not a solution. We need to figure out alternate way to do those things. So I don't think there is any very completely different approach to it. It's just going back to first principles, going back to the fundamentals, right? So nearshoring, the localization, addressing the supply chain cost and risk. And now with AI available, you can do those risk assessments pretty quickly and do those simulations like I talked about in manufacturing. You can do this multiple simulations to not eliminate but minimize your risk, right? You can know, nobody knows today if something happens in one of the ports 3 months or 6 months down the line, probably your OEM might have an impact, but they don't know at that time. But can I build those scenarios? Right? Those are all the places where you have capabilities to take advantage of AI and then said, okay, these are my risk profile has changed. How do I mitigate it? And can I use this period? Otherwise, you will only know when the truck doesn't turn up, right? So those are things that we can do. There is always collaboration, better forecasting, better transparency and communication. Consider supplier as your partner rather than a supplier, right? So those are standard ways that we used to talk about in the past, but they're much more meaningful. We have to make the supply chain more and more resilient to these shocks and those shocks won't go away. Those will be there. Our job is how to manage those.
In everything that we've talked about here, it seems like the common thread is connectivity, right? So from the consumers in the car, their expectations of what they want from a car, to the software, what would we call here, the software defined vehicles, to digital twins and sensors, to autonomous cars. All of this means there's this infrastructure of connectivity, wireless, mobile connectivity. That also must open up the door for and create a lot of vulnerabilities in the cybersecurity space.
Yep.
I mean, how is automotive manufacturing and automotive companies dealing with this? I mean, how are they looking at it? Are they having to spend a lot more money on security than they used to?
See, definitely cybersecurity is a massive challenge. The more connected assets you basically have additional vectors that are open, right? You have more nodes, more vulnerabilities that gets built in. So as we get more and more connected, this becomes a much larger challenge than what it used to be, right? So I'm sure we have all seen or witnessed cyber attacks stalling entire production and supply chain in the last few months in the automotive ecosystem, right? It will only increase and that predominantly because of a lot of legacy technical debt, technical estate that they have. If the technical upgrades don't keep in touch or don't catch up with the advancements in the connected capabilities, you expose your organization to vulnerabilities, right? But also there is a view which I think it's still being explored, that is AI that good in defense? While AI is good in attack, but is it good in defense? Right? How do I bring AI to work with human intelligence to build that defense capability when it comes to cybersecurity perspective, right? So again, in automotive, it's much more critical that we are talking about vehicles. If a vehicle gets hacked and certain things happen, it can be pretty disastrous pretty quickly, right?
Oh,
So
yeah.
how do we bring in that into the both the product design and the security of the vehicle while it's on the road, right? So that's very critical. And while it has been talked a lot, when, like I said, when the vehicle were just connected, there's a lot of approaches to that. But now when you're controlling the vehicle with 50% to 70% software, that exponentially increases the challenges. So it's very critical, and we need to be very sure of addressing that in when it comes to the vehicle as an asset.
So finally, PLN, when you imagine walking through an automobile factory 10 years from now, so let's say 2035, let's put on our futurist hat, look to 2035. What do you see, hear, smell, and feel in that factory? How's it different? Paint us that picture.
So definitely, I would see, like we talked about, a significant amount of physical AI integration into the manufacturing process. So I would definitely see humanoids, quadrupeds, all other forms of physical AI assets working in close collaboration seamlessly with humans, and where humans have more of the judgment role in the plant, and the execution capabilities are with robotics and the humanoids, right? That's definitely something that we see it, and it's close to reality. It will happen. There's a lot of automation that and significant uplift in efficiency of those plants, right? So that's definitely going to happen. Plants will have to become kind of modular micro factories instead of that mega manufacturing processes that we have, right? 3D 4D printing, again, that's a technology that's worth exploring. 4D essentially is products that adapt and change after they are being manufactured.
Wow.
Right? So those are integrating that into the manufacturing process, highly sustainable and software defined manufacturing process, right? Not completely automated, not lights out, not dark factories, which is my view, but we will have a completely integrated ecosystem of human machine collaboration, right? That's definitely the future of manufacturing as I see it.
PLN, thank you so much for sharing your insights with us. And for all of you out there, if you enjoyed today's conversation, please subscribe, share, and join us for more episodes as we continue exploring all different aspects of humans and machines, and us all working together to co-author the future. Thank you very much.
Thank you, Kevin.